Yeah, and meanwhile, I can say Daniele is a professor of multimodal learning technologies at the German University of Digital Science, and he leads the research group on augmented feedback and coordinates the master in advanced digital realities.
Yes, exactly. It's a new position I took over since April 1st. Before that, I have done my studies. I am originally from Italy, where I studied computer science, and I specialized in the Netherlands. I did the master in artificial intelligence and a PhD in learning analytics. And during my PhD, I worked on different projects, and that's where I also got to know Fridolin in one European project. And since 2020, I moved to Germany, where I have been working at the DIP, which is Leibniz Institute for Research and Information in Education. And as I said, since recently moved to the German UDS as professor. And in this presentation, I will try to summarize a bit the research endeavors that I'm doing. I decided to focus on particularly on the project that I'm leading, and trying to get deeper into this project rather than just showcasing many other things that I'm doing at the moment. But before going deeper into this project, I would like to explain a bit why I am doing what I'm doing, why do I think this is relevant, the research I'm doing. And I think we, first of all, are facing growing world population, and together with it, of course, we have a growing educational demand. And therefore, also, we are faced with challenges such as migration and the fact that we need to educate people, especially those that are low-skilled individuals. And therefore, and a way to address the skill gap that we are facing, and also induced by automation, the fact that many jobs are becoming obsolete. Also now with the introduction of ChatGPT, many jobs are disappearing and so on. A way to one let's say responsibility is of course higher education, which at the moment I believe that is struggling with providing skills and competencies for people in terms of because it is structured traditionally around degrees and courses and certifications, but also it faces other problems like limited teachers. And therefore, I think in general, what we need is better access to learning and training experiences, but also better access to feedback, as well as guidance and more opportunities to practice. And in this sense, I think digital tools are offering new opportunities to provide this, let's say, wider access to learning and training and practice. In my research, I have been dealing on how to develop skills across what I call physical and digital spaces. I also did a PhD at the Open University, so a distance university in the Netherlands. And also now I work for a distance teaching university. But I also was very much interested in how people learn skills, also particularly in the physical space, because I always thought that the way how digital learning is conceptualized of students sitting behind the desktop is very much limited, because there are multiple multiple skills that people cannot just simply learn behind a desk, multiple skills that require physical interaction. Plus, nowadays, we have a variety of devices, a variety of tools and affordances that can facilitate learning in more authentic spaces. I'm thinking, for instance, about sensors, about wearables, about augmented reality on using smartphones, or also about new devices that had head-mounted displays like the Apple Vision Pro, and which are becoming increasingly more available. And as I said, there's a variety of different skills or activities or sports or professions that require physical interaction, that require body coordination, that require interacting with physical objects, which of course are it's really limited to be executed, to be done in with the typical computer and desktop screen sitting behind a desktop. So my research has been focusing on how to develop skills. And when I talk about skills development, I mean trying to bring the novice into a level of an expert. And in particular, as I said, leveraging the data that comes from multiple devices. And this is these devices produce a variety of data and also provide variety of interfaces and interaction affordances. And my idea, my research approach is to combine this with a learning analytics approach, which means measuring, collecting, analyzing data about the learners. And what I think the benefit this approach provides is that it gives a more accurate representation of the learning process. And also it provides the students the possibility to practice more authentically. So to practice, for example, in the location where the skills is going to take place. So it provides, compared to the desktop-based type of learning, provides the possibility of also practicing skills in the real world, so to say. My idea is also that I'm trying to push in my research is to conceive the support of especially of artificial intelligence as a tutor, and in particular as a coach. So we have been also doing various projects together with the sports coaches and in the area of sports science. And I think I find fascinating of thinking about AI as AI tutors as coaches. So basically that and that support that does not only show you the correct solution, but also does not tell you, okay, this is right or wrong, but actually helps you to achieve and set and achieve realistic goals, and also develop training plans, and also provides you with motivational feedback. For instance, you can do this, or invites you to practice regularly. Okay, so this it's more like a general background on my research, and now I move to the use case that I will be presenting here. As I said, this general framework is particularly valid for any kind of skills that has a psychomotor component, for instance, skills like sports or simulations or any kind of vocational training that has some physical components and so on. But also 21st century skills. In our project, we focus on oral presentation. And this is a very relevant skill that everyone or most of people should learn in their job. And it's also something very relevant for higher education because students need to learn how to present their work. And it is something, unfortunately, that is really poorly taught in higher education institutions. There are, of course, many presentation training courses, and those are more or less, let's say, mandatory. But in general, there are few opportunities to practice presentations, and my perception is that teachers and lecturers do not really give the right importance to presentation, especially how the presentations are delivered and how to improve the presentation. If you think about, for example, the last presentations that you have attended at a conference or at the university, it may be very typical often to recall presenters that are not so outstanding, right? That, for instance, do very typical mistakes like talking to the air or not addressing the audience or looking at the slides or, making various types of mistakes. And so this is somehow an aspect that we wanted to dive into more in depth. And in order to do that, we have basically talked to presentation experts, and we figured out that basically there's various things that make presentation effective, right? For instance, if we watch the TED Talks, we can see various, amazing presenters. So, but an effective presentation depends on multiple things, depends, for instance, on the skills of the presenters, depends on the topic, or depends on the audience, whether, it's appropriate to do something in front of a specific audience, depends on the content you're talking about, depends on the goal. So there are basically many variables in a presentation, so it's not so easy to say, okay, there are very, things that are always right and things that are always wrong. So there's basically what we gain from presentation experts that it's always kind of depends what is a successful presentations. So sometimes you can see, for instance, a presentation that only uses very simple text on the slides, but for specific context that the presentation can work well. Sometimes, the speaker talks too fast, and that's probably inappropriate for certain contexts, but appropriate for others, and so on. So, as I said, no clear right or wrong in presentations. Also, what we figured out from experts is there are 4 main aspects to prepare an oral presentations. First of all, one needs to research the content of what needs to go into the presentations, and then it needs to compose their presentation. So it needs to basically make a plan of what to say. and after that needs to design the slides in case the slides are used, and then practice, so rehearse the presentation. And depending whether it's online or it's face-to-face, there's different ways of delivering the presentations. Our interest in presentation derives also from the past research experiences. Particularly, a colleague of mine, Jan Schneider, has developed a tool in between 2015 2019, which is the presentation trainer, and which can be considered, it can be classified as OPAF, that stands for Oral Presentation for Automated Feedback System. And the idea it works as an augmented mirror. So you basically present in front of the camera and you receive feedback about your performance. For instance, it would ask you to reset your posture if you're not placed correctly, or it would tell you to speak faster, speak slower, and so on. And this idea, we found this idea really fascinating, and we wanted to build on that because we found several points of improvements, but particularly the fact that the presentation training was only specifically looking at focusing on rehearsal, and also was relying on Microsoft Kinect, which is a specialized depth camera that only work with Windows. While of course, since 2015, technology has developed to the point that now also webcams have the capabilities of doing a similar type of tracking. So in 2022, we got a project funded by the German Ministry of Education called the HITE, that stands Model for Hybrid Teaching. This project was in collaboration with the Cologne Game Lab. And the idea of the project basically was to specifically look into how AI tutors, like the presentation trainer, can be mainstreamed in education. That means figure out how to make these tools generally more adopted so that teachers can and learners can actually use this and improve their presentation skills. And obviously with increased user adoptions, there's many other type questions connected. For instance, how is the role of the teacher evolving, and how do we make the design of such tools more responsible? And this is, in a nutshell, the scope of the HITE project. And the HITE project, in the last 3 years, because now it's coming to an end, has developed Presentable, this new presentation trainer that I'm going to introduce you. And I'm going to show you the different research questions connected to this tool, and also the research methodologies. But before doing that, I would like, first of all, to thank the team that have made Presentable now a reality, so to say. This team is composed by Jan, Nina, and Stefan, that are the main researcher in the project, but also is composed by the research assistants and research developers, and also by some guest researchers that have helped us shaping or investigating various aspects of Presentable. As I mentioned before, one objective of Presentable was to making sure to design an AI tutor in a responsible way. And in order to do that, we decided to adopt a design-based research approach with some participatory methods, which means we included from the beginning experts in our methodology, in our design. So we first interviewed the presentation teachers, so people that are experts with presentation training, and also at the same time we analyzed related systems. These both perspectives, let's say, fed into the first requirement analysis, which constituted, let's say, our first design and implementation. And that led to two different prototypes that I'm going to show you in a second. And we tested these prototypes first separately, and then we combined them into an integrated prototype. And from that point on, the Presentable software in its current shape sort of took shape. And then we started a new reevaluation with the experts. And currently we are in step 7. We are currently doing a pilot with students. They're testing the new software. And there are going to be other steps, probably beyond the project itself, where we are going to test Presentable also in actual classrooms. I've mentioned there are 4 main steps in presentation preparation. We decided basically to focus on two steps. The first is message composition, and the second is rehearsal. And the 2 main questions then became, first of all, how do we support the message composition by means of software, or let's say computer program? And that led to create some approach that came up with a guided approach that we called guidance, which is a process that guides the user to prepare and compose their presentation. So that would be the first main research question. The second research question, of course, is how do we support the rehearsal of the presentations? And in that sense, we focused on 2 things. The first one is how do we make sure that students, the users, basically practice, and particularly, how can they practice specific sub-skills of the presentations, for instance, verbal or non-verbal communications, or memory, or gestures, and also how they can receive feedback from the tool. How can we program an intelligent support that provides automatic feedback? And yeah, so I mentioned we first had 2 separate prototypes. The first one on the message composition, mainly led by Nina, and it looks a bit like a guided interaction with a chat, with an avatar. In our case, is a parrot that is speaking to you. It's not using a large language model. Instead, it's using scripted messages. And basically, first let the user think about what are the main points they want to mention in the presentation, what they want the audience to know, and then it guides them through, composing introduction, conclusion, and middle part of the presentation. and also provide some suggestions. So basically guide them through into planning, into composing a powerful presentation. The second prototype is WebPose that has been led by Stefan and Mohammad. And basically there, the idea was to use a camera-based, to use a webcam instead of a Microsoft Kinect to detect mistakes. For that, we use Google Media Pipe for landmark detection. And using Google Media Pipes, which is built in JavaScript, allows it to run on the browser, so on the client, which means also minimizes the exchange of the data between client and server because all the, let's say, computation is done locally on the browser. And yeah, and this basically first prototype detected mistakes such as arms crossed or standing on the side, so not facing the audience, or arms raised, and so on. Here's a picture of summer school in technology enhanced learning last year in Italy, where we tested these two prototypes separately. We also had a demo session where we asked people to try it out. This is also where last year Fridolin had a keynote speech at the Jada Summer School. Yeah, and after that, I mentioned there is a second iteration where we combined these two prototypes together. And this has started since, let's say, a year ago. And now the two prototypes have been merged into one single, let's say, software, Presentable, which gives sort of a unified user experience to the user. They can first, let's say, or create a new presentation and compose their message, create a structure of the presentation, and then move to rehearsal and activate the webcam and basically practice the presentation in front of the camera and receive automatic feedback in case they make some mistakes. And obviously they can rewatch the presentation, check if they're happy with it, or repractice again. So this is, again, a tool that is meant to be used at home to practice and prepare and practice the presentations. There are other relevant and, in my opinion, exciting questions about this research. First of all, the main question is how do we engineer meaningful feedback with this Presentable? What poses and gestures can we detect additionally using the camera? How do we make the feedback more adaptive to the individuals? How do we make sure that the analysis of the verbal communication is automated? How can we keep the teacher in the loop? And what is actually changing? How is the role of the teacher changing? To what extent it makes sense to use machine learning? Is there a space for generative AI in this tool, or how do we train people using slides? How do we measure practice, and so on? The first one I mentioned is feedback engineering, and this is I'm particularly enthusiastic about this research strand, let's say, because I think it's really hard to create meaningful feedback. We now focus on immediate feedback because it is more effective. We found out it's more effective than delayed feedback. Also immediate feedback, like for instance, lower your hands, This is as basically you have no time for explaining a lot. So the message needs to be concise. And also the user that is presenting and receiving this feedback does not really have so much capacity to process long messages. So it needs to be simple and actionable messages, whose probably meaning has to be ideally already known by the user. This is showing how we collect the data from Google Media Pipe, gives a landmark position for each relevant joint of the skeleton. There are, I think, 32 key points for the pose landmark. And here on the right, you see we have a specific tool for visualizing the data we collect from MediaPipe. And you see here how it looks. Basically the data in correspondence with the video. So each particular pose is tagged into the video, into the data stream. And you see this particular pose is hands close to face. And this would correspond or not to some specific feedback. The other research questions that we are figuring out is how to improve the pose detection. At the moment, we are using some simplistic rules. For instance, we look at the media pipe data. If the joint of the, let's say, hand of the finger goes close to the joint of the eye, then we set is hands close to face to true, and we generate the feedback max message, lower your hands. And the current poses that we have implemented is turning side, or hands close to face, or crossed arms, or crossed legs, or no hands visible. For example, when people are, keeping their hands behind the body, or hands are in pocket, or hands are fidgeting or playing. Yeah, and we are looking with a master thesis student, we are looking how to extend the detected poses using also hand pose API, which is an extension of Google Media Pipe. And this is also very exciting research work, because there are various poses, like, for example, counting from 1 to 5, or reading from notes, or various types of typical gestures that happen in the presentations. And we are checking to what extent we are able to create rules that we can, let's say, detect those poses. There's a lot of space for improvements, specifically for the feedback, because the feedback we are giving now, it's only corrective. So we are not using positive reinforcing feedback. And also we are using the approach that each pose basically corresponds to a mistake. So for instance, when the hands are high, it gives the feedback lower your hands. But obviously this is not always the case. Not all the presentation poses are mistakes, and therefore this will require to change the feedback logic. And also, so body posture considers only body postures. It does not consider other verbal communication, for instance. And one big issue is, how do we combine different modalities? So how do we match what is being said with what is being, let's say, acted? So for instance, if I say, I'm going to say 4 things, how do we match, how to make automatically analyze what I said is matching with my nonverbal communication. Also, how do we distinguish intentional for non-intentional gestures and so on? Yeah, there's also working to making feedback more adaptive. This is research from Paula. Basically, now the feedback we are giving is the same for everyone. But what if the users have executive function difficulties, for instance, people that have attention disorder? This would probably need more guidance or different types of feedback. So we are figuring out to what extent can we make feedback more adaptive, especially looking at people with executive function difficulties. So this is quite an open research question. Also, verbal communication is, as I said, very much an interesting topic, because we can look at prosodic features, so intonation or use of pauses or volume, but also we can look at the semantic, what is being said. Currently, we do speech transcription, so we basically transcribe what people are saying. We use OpenAI Whisper for that. But obviously, if we want to automatically analyze what they are saying, we need to do real-time transcription. At the moment, the transcription is only done after the presentation. An additional point is, how do we keep teachers in the loop? So we created a dashboard for the teachers to watch, and that can have an overview of the presentations. And also the idea is that in the future they can give specific feedback on, for instance, they can highlight parts of the transcript and give feedback on what has been said in the presentation. But obviously, we are not sure if teachers are actually even willing to spend time into reviewing presentations. Actually, from what we know from experience, that teachers have in general limited time. So another colleague, Victor, is trying to understand how the role of teacher change, and is using the construct of teacher agency. So trying to understand, and is doing a SWOT analysis with teachers, basically asking, are you inclined to use Presentable? If yes, how will you use it, and so on. This is a little bit the difficulty of this type of research. We are inventing a system that the teachers are not really entirely sure how to use, and there are multiple ways how to use it. Quickly on the next part, basically another issue is what if the generated feedback is misleading or is incorrect? For instance, let's see this feedback message. What if this is not correct, right? What do we do about it? We are preparing a flagging system that the user can basically flag specific feedback messages, but also a system that the teacher can review those feedback messages that have been flagged. This approach is, so far the feedback messages are, as I said, computed to rule-based, and this means they are fast, but obviously correcting them, it's tricky. So what we are also thinking to do is using machine learning models that can classify, for example, specific mistakes. This has already been, we have already done in a different project. However, this requires, let's say, the real-time streaming of the data. You see, for instance, this time series data, the data we collect from MediaPipe, needs to be streamed and classified with pre-trained models. So it requires, let's say, a more complicated architecture in order to do that. Finally, I want to conclude, using generative AI. At the moment, we are not using Gen AI because the teachers, basically presentation experts, did not recommend it, because obviously the purpose of this tool should be to train your presentation skills. And so the Gen AI here is seen as something that does to work for you, right? And so takes you away the chance to, practice yourself. Also, with commercial models, we would face a huge privacy problem. So obviously here we are dealing with students' data. We don't want to hand over data to commercial models. And also, we tried to generate feedback with the vision models. So models that, large language models that take input as videos, but we found the output quite inaccurate at the moment. So we're still figuring out. Our idea is to match the message composition, so what you're planning to say in your talk, versus the transcript, so what you actually say in the talk, so to match if the plan versus the reality is correct. And this can be something like a task that is suitable for a generative AI model. I think there's a lot of additional work. I don't have time to go through this slide analytics or mini games. So there's a lot of other research ideas that we want to, combine into Presentable. I hope that somehow this presentation gave you an overview of my work on augmented feedback, I call it. And I prefer that maybe we use this time for some questions. Thank you very much.